In the vast, silent theater of the cosmos, our solar system performs a predictable clockwork ballet. Earth, our solitary blue outpost, follows its designated path around the sun. But what if this delicate equilibrium were fundamentally challenged? Imagine an object of almost inconceivable density, a true gravitational monster, appearing without warning in our immediate cosmic neighborhood. This is a thought experiment grounded in physics. We are exploring the arrival of a stellar mass black hole, mass of a star, compressed into a sphere only a few kilometers wide, placed just beyond Neptune's orbit. This isn't about explosions or Earth being swallowed whole. The reality is a cascade of subtle, profound consequences. Its influence would be a slow, inexorable pull on space-time, tugging at distant Kuiper Belt objects, tugging at the very ground beneath our feet. The first signs would be almost imperceptible, detected only by our most sensitive instruments. Small, inexplicable deviations in outer planet orbits, deviations in moon's paths. For humanity, the initial impact is confusing data in a control room. Anomalies scientists struggle to reconcile. This is detection, analysis, and the dawning realization of what it means for our future. We'll calmly examine real-world effects on global infrastructure. Our network of satellites, navigation and GPS, Earth's geology, its oceans, its atmosphere, from first astronomical alerts to disruptions in global supply chains, financial markets, power grids that sustain daily life. What happens when a black hole arrives at our doorstep, forcing us to confront the fragility of systems we take for granted every single day? The first tangible technological consequences were already unfolding in low Earth orbit. The intricate web of over 9,000 active satellites. Each satellite maintains altitude and position through tiny, calculated thruster burns. The sudden introduction of a new, powerful gravitational source would render prediction models obsolete. Operation centers like the US Space Force would begin to register accumulating errors. The satellites of the Global Positioning System would be among the first and most critical affected. The black hole's new gravitational field would introduce a subtle but compounding time dilation effect. Navigation apps on smartphones would become unreliable, showing drivers in adjacent streets or even in bodies of water. The global financial system, which uses GPS timing to synchronize billions of transactions, would face chaos. Automated high-frequency trading algorithms, unable to verify timing, would automatically halt. With orbital paths becoming increasingly unpredictable, the risk of satellites colliding would skyrocket, setting off a chain reaction of further collisions known as the Kessler syndrome. Satellite operators would be forced to execute emergency maneuvers, burning precious fuel. The most dramatic and visible consequence would be the disruption of the tides. During periods when the gravitational forces of the moon, sun, and black hole aligned, coastlines would experience perigean spring tides of a magnitude never before recorded. Low-lying cities like Venice and Miami would face unprecedented and persistent flooding, overwhelming their existing sea defenses. It would cripple the world's major ports. Giant container ships would find themselves unable to enter or leave harbors. Meteorologists would find their predictive models failing. Established patterns like the El Niño Southern Oscillation would become erratic. The additional gravitational stress from the black hole would act as a trigger on these pre-stressed fault lines. Within the first days and weeks, seismologists would record a statistically significant increase in the frequency of minor earthquakes around the globe. The risk of a big one hitting a major metropolitan area like Tokyo would rise dramatically, forcing governments to issue unprecedented geological hazard warnings. This heightened seismic activity would be mirrored by an increase in volcanism. Areas near supervolcanoes, like Yellowstone, would be placed on the highest alert level. Infrastructure in earthquake-prone zones would be under constant threat. The persistent, low-magnitude shaking would cause cumulative structural fatigue. The ground beneath our feet, the ultimate symbol of security and permanence, would now be part of the unfolding crisis. With maritime trade crippled, the just-in-time logistics that form the bedrock of modern commerce would cease to function. Supermarket shelves would empty within a week. Facing systemic risk on a scale never before imagined, governments would be forced to shut down stock exchanges indefinitely. Increased seismic activity would threaten the structural integrity of oil refineries, forcing many to shut down as a precaution. This would trigger rolling blackouts and severe energy rationing on a global scale. Currencies would lose value. The price of essential goods would skyrocket, leading to the emergence of barter systems and black markets. The initial phase, mass migrations on a scale never before seen. Billions forced to abandon low-lying coastal zones. An unprecedented refugee crisis emerges. Not refugees of conflict, but people fleeing planetary physics. Central governments can no longer project authority. Power devolves to local leaders and armed militias. The nation-state ceases to be the primary organizing unit. International cooperation evaporates. Conflicts over the few remaining stable, resource-rich territories are likely. The concept of a future, planning careers, saving for retirement, becomes a luxury. Focus narrows to immediate survival. Millennia after its arrival, the black hole's presence would have forced the solar system into a new equilibrium. The long-term orbital fate of Earth would be one of three primary possibilities. Possibility 1, a new, stable, but more eccentric orbit. Civilization surviving underground, emerging only during brief temperate springs and autumns. Possibility 2, a slow, multi-million-year orbital decay. The black hole saps Earth's orbital energy. Regardless of mechanics, the long-term outcome is regression and resilience. Global interconnected civilization becomes a distant memory, a legend of a calmer age. Astronomy becomes essential, not curiosity, but survival. The appearance of a stellar mass black hole serves as the ultimate stress test for our civilization. It is not a narrative of sudden, cinematic destruction, but a slow, methodical dismantling of the stability we take for granted. This thought experiment reveals a fundamental truth. Our complex world operates on the assumption of a placid and predictable planetary environment. The global machine of commerce and information, already proven to be brittle, would be shattered beyond repair. The story of its arrival is a humbling lesson in vulnerability. It underscores the profound fragility of our interconnected world. What scenario should we explore next? Share your ideas below. You've been watching IfVerse, where imagination meets possibility. See you in our next reality.